All right. So we have practiced a fraction times a fraction. Here is a whole number times a fraction. And before we just do the flat out multiplying, I want you to see what 3 times 2/3 looks like. I want to remind you what 3 times 2/3 looks like. Remembering that we could call this 3 whole groups, because that's a whole number, 3 groups of 2/3. So right now I have one group of 2/3. Now I'm going to copy and duplicate it. Now I have 2 groups of 2/3. Now I have 3 groups of 2/3. So if I wanted to say now how much I have all together, I can count them. I have one, whoops, let's try that again. I have 1, 2, 3, 4, 5, 6. I have 6 total parts, but each whole is cut into 3. So my answer would be 6/3. So why this is really super important is because when kids try to do the method of just multiply across, so I'm going to write this on the other side, 3 times 2/3. When kids try to multiply across, they say 3 times 2 is 6 and 3 times 3 is 9, and they get answer of 6/9. This isn't right. A reminder that 6/9 looks like this. 9, okay. Bring it over. 3, 4, 5, 6/9. Here's a picture of 6/9. So that is very clearly different than what we have on the left side. I do want you to notice that 6/9 is exactly the same as each one of these pictures over here. So 6/9 is the same as just one group of 2/3. That's how we know that we don't multiply the top and the bottom by the whole number. All right. If you look back at this picture on the left, we can see 1, 2, 3 groups of 2/3. The 2 gets repeated over and over. The numerator on the top, here we go. The numerator on the top, 2 gets repeated. Here it is, and here it is. The denominator doesn't get repeated because the denominator is just telling you how many goes in each rectangle that we make. So if I want to multiply this, I can either say all I do is multiply the top number. 3 times the numerator 2 is 6, and the denominator stays the same. That works. Or, and this is what I really suggest for kids, is to rethink the way that we view this number out in front. If it's a whole number, if I wanted to make 3, I would grab a bar and I would say, how many parts? Well, if I wanted it to be a whole, I could just leave it the way it is. And if I left it the way it is right now, this is one part. Do you see it? It's one big box. It's one part. So if I wanted to have 3 wholes, I would have this, all right? So this could also be written as 1 part out of 1. So if I wanted 3 wholes, it would look more like this. Grab what I need here. I would paste and I would paste. It would look like that. And each one would be 1 on top of 1, 1 on top of 1, 1 on top of 1. And we wouldn't call that 1/1, right? This fraction right here is not 1/1. We call this 1 whole because there's only one piece in each rectangle. All right, here's why this matters. Because if I have 3 wholes, if I have the, let's see, Mrs. Toivola, you can do this. Delete, delete, delete. I'm going to rewrite this one more time. Instead of writing 3 times 2/3, which is what you see above, I could change that number into 3 as a numerator and 1 as a denominator. All right, 3 on top of 1 is 3 wholes. It's not 3/1, it's 3 wholes times 2/3. Now if I multiply across, 3 times 2 is 6, and 1 times 3, try again, 1 times 3 is 3. And that answer matches the answer we got first. It's a really great idea to take a whole number and write it on top of 1. So that way you don't accidentally multiply the whole number by the denominator. But some of you might have noticed that 6/3 as an answer isn't a great answer, because that can be simplified. I could take this piece right here and move it up here. I could take this piece right here. Try again, Mrs. Toivola. I keep grabbing the wrong one. I could take this piece right here and move it right there. Now I can see that 6/3 is really the same as 2 wholes. So let's go back to what I was teaching the other day about simplifying before we multiply. So I'm going to write 3 times 2/3, and I'm going to rewrite that immediately as 3 wholes times 2/3. I can see that there's a numerator and a denominator, and again, most of the time it's going to be diagonal. It's going to be on top on one side and on the bottom on the other side. That there's a numerator and a denominator that I can divide by the same number. And that one is right here. It's the 3's. I could rewrite 3 as 3 times 1 and 3 times 1. And then I keep everything else the same. There was a 1 on the bottom, there was a 2 on the top, and a times. Now, when I see a 3 on the top and a 3 on the bottom, I can cross them out. Here's a 3 on the top and a 3 on the bottom, right? We haven't really talked about this, but I could cross out a 1 on the top and a 1 on the bottom, because 1 on top of 1 is a whole, 3 on top of 3 is a whole, 3/3 is a whole. Now take a look. I only have 2 things left. I have to pick a color here. We'll go with red. I have a 2 on the top and I have a 1 on the bottom. So this is 2, and this isn't 2 once. This is 2 wholes. Another thing that your 4th and 5th grade teachers might have taught you is that 2 on top of 1 is the same as 2 divided by 1. So how many 1s are in the number 2? How many wholes are in 2 wholes? And the answer is 2. All 3 of these are the same. And again, I want you to notice this is the same as the answer we got on the other side.